On behalf of INSDAG, I welcome all participants to today's webinar on Osdag. We are pleased to see participation from industry professionals, faculty members, and a lot of students as well. As this is a very brief webinar, so I'll quickly try to set off things. I'll invite DG INSDAG, Shri PK Mishra, to deliver the opening remarks for this webinar. Over to you, sir.
Thank you, Munir. Good afternoon, Professor Ghosh. My dear friends who have all participated, I sincerely welcome you to this webinar. Professor Ghosh has been a long-standing patron of INSTAG. INSTAG, that is Institute for Skill Development and Growth. I'll request all of you, those who don't know about INSTAG, to have a look at our website to know the list of activities that we are doing, what have been our achievement, what are our objectives. I will just briefly take you through our objectives. This institute, which was set up in almost 30 years back by Government of India Ministry of Steel, along with major steel producers like Tata Steel, JSW, SAIL, RINL, and ArcelorMittal. The major objective is to promote usage of steel in construction. You know, per capita consumption of steel in the country is not that high. It is hardly 105, 106 kg now with revised, estimate of the consumption, whereas the world global average is about 225 kg. So we have a long way to go. We are aspiring. We are growing in a great aspirational manner, whereas our steel consumption should be much higher than what it is presently today. That's the reason why we are trying to promote the usage of steel among the professionals, among the architects, and we are also trying to help the professionals, help the students to know a little more about steel design, because that topic doesn't get adequately addressed in the undergraduate stage. And Professor Ghosh will also support this idea that students who do not know much about steel design, whereas in workplace they are required to work in steel because steel usage is growing, you all know. So how do you meet this gap? How do you bridge this gap? That is where INSTAG is working on various training sessions, seminars. We are doing a lot of studies. We are also trying to take the help of IITs and good academicians like Professor Ghosh, Professor Satish Kumar of IIT Chennai, Dr. Madhavan of IIT Hyderabad, PC Ashwini Kumar of IIT Roorkee, and a lot of other eminent academicians and experts are associated with this institute. I'll also request the professionals who are present, whom I am not able to see, I'll request please extend your support to this institute, which is a not-for-profit organization. We are not making profit in our activities. We are only trying to propagate the knowledge of steel usage or steel application among the professionals. So this is what is a small objective. And this webinar on Osdag, that Open Steel Design and Graphics, which is being conducted with help of Professor Ghosh and the Osdag team of IIT Bombay. I sincerely thank and appreciate their efforts in developing and advancing this indigenous FOSS platform. And we are only trying to extend this support to Professor Ghosh and his team so that whatever work he has done, whatever initiatives have been taken, that get propagated among the interested participants. I'll just leave with a small input. We have done number of training programs on various aspects of steel application during last year. We have also made a training calendar now for this year, 26-27. Please see our website. You can have a look at the training programs. And in case you want some more topics to be addressed, which are useful in the marketplace, you can also suggest to them. Because we are trying to bring in apart from our in-house expertise, we are trying to borrow the expertise of experts like Professor Ghosh, and we are trying to make this kind of seminars or online training programs or other events whereby the professionals and students get benefited. So Last year we have covered almost 1200 professionals and students in our various training programs. We have also launched one teaching resource materials on steel design. It is available on our website. This is a very good book which has been updated with help of Professor Madhavan of IIT Hyderabad. You can see various aspects of steel design and in one place. And we are also going to offer another teaching resource material on for architecture, students of architecture. That is going to come up in next 2 3 months time. So these are various. You can see our various publications. We are making very small efforts. I am not saying that the great efforts you are making, but you can help us. You can suggest. You can collaborate. You can participate in our program. You can also guide us how our efforts can be more focused and useful for professionals and students who are interested to know about steel design. Thank Mr. Ghosh again, Dr. Ghosh once again. Thank you.
Thank you, sir, for those opening remarks. In fact, to add to sir, INSDAG has been a long standing supporter of Osdag and its objectives. In fact, Osdag demonstrations have also been part of our training programs. With the most recent session that was conducted in IIT Roorkee, so Osdag was part of that as well. Now, without wasting any time, I'll invite Professor Ghosh, Siddharth Ghosh, and his team at Osdag to present. But before I do, I think a lot of new participants are there, and it is also live streamed on YouTube. So I'll just briefly introduce him to our audience, although he doesn't need any introduction. He's a well-known name in this fraternity. Uh, so Professor Siddharth Ghosh is a professor in the Department of Civil Engineering at IIT Bombay. He obtained his PhD from the University of Michigan in 2003 and joined IIT Bombay thereafter, where he has held several academic and administrative positions. He has undertaken extensive research and consultancy assignments in structural dynamics, reliability, design of steel, and reinforced concrete structures. He is an active member of several BIS committees related to steel structures, structural safety, and special structures. And he also serves as the convener of the BIS community developing the Indian standard on tensile membrane structures. Also, during the academic year 2014-15, he was on a sabbatical as a guest professor in the as a chair of structural dynamics and earthquake engineering at ETH Zurich. He is currently the JK and MG Mehta Chair Professor of Structural Engineering and the Professor in charge of Structural Safety, Risk and Reliability Laboratory at IIT Bombay. With that, I would now like to hand over the session to Professor Ghosh and his team. Over to you, sir.
Thank you and good afternoon to everyone. Munib, thank you so much for this introduction. And also, I'd like to thank Mr. Mishra and the whole INSDAG team. Like Munib was saying, INSDAG has been a part of our journey at IIT Bombay, OSDAG's journey at IIT Bombay, almost from the very beginning. So, this is a continued association, and we are both happy and proud about this association. So Munib said that it would be a brief webinar. So we are trying to do it that way. Let's see, I mean, how much we can achieve given the short time. I can already see that on the chat box there have been questions how one can install the latest version, etc. So yes, you try to answer those questions. But before we get directly there, I'll go through certain introductory remarks. I think these are very necessary. Maybe students will get a little bored, but I think for professionals and others like me who have been with this steel structure related awareness and promotional program, for them I think to say these words are very important. I'll start. So this is basically an introductory presentation on Osdag, which is a free software for structural steel design. We'll come to the word free in different ways. Hands are being raised to ask questions, but maybe with permission of Munib and others in INSDAG, we'll leave it for the very end when the questions can be collated by Munib and his team, and maybe we can answer them at a later stage. So this is how the outline of today's lecture is, and to your right side you can see the different links that we are providing. You can take a screenshot of this, but not so necessary. So we'll start with the introduction of Osdag. This is basically a slide which I presented in another webinar which was also organized by INSDAG, where we were discussing how the steel software evolved, not only steel, design software evolved over last 60, 70 years. So long back before 1980s, we were mostly doing with manual calculations, and we did our checks based on whatever codes and standards we had. And then slowly moved on to things like STAT 3, which came in the mid 1980s, and people could do the analysis and do some pass fail checks, and things moved ahead, and in this century, in the early 2000s, we saw that many open source software started coming, not in the design field, but at least in the analysis field, something like OpenSys. So things move ahead, and tools like SAP 2000 and it has become quite efficient and also quite popular in the media. But what we also see that although our industry in India dealing with the steel structural design started using this software, and not only the steel design industry, but the civil engineering community as a whole, we started using that. We still didn't reach what we expected in terms of software development, in terms of usage of software, and when I say usage, making efficient use of it. So that really didn't happen. So let's try to take a look at what we are looking for when you are thinking of a modern structural design software. What do we need from a software like this? Obviously, the first thing is that the software should be accurately interpreting the clauses in the design codes, design standards. That's the most important thing. Also, you want transparency in design calculations. That means you should know that it's doing it correctly, and if I am not doing the design, I am reviewing the design, then also I should be able to know. So it would give us a smooth collaboration from the architect to the structural designer to the contractor. Basically, it will try to give a workflow which can be easily automated, and it would play a role in that automation of the workflow. And also we need that there should be some interoperability with related software, because when you are doing structural steel design, you are not talking only about a project where you are designing a steel member. You are dealing with a project where there is geotechnical work like excavation, foundation design, where there is some manufacturing involved. So all of these are there, and that's what we should have, an interoperability with the connected software that relates with the drafting, etc. And obviously it should be easy to learn and use. It cannot be too complicated, because the learning starts at the college level, where undergraduate students who are dealing with steel structures for the first time, or any structures for the first time, they should be able to approach this software and use it, right? So that's also a very important criterion here. And more advanced requirements are there nowadays. People will talk about parametric design. Can I optimize my design? It's always a goal to optimize, right? And then we also start building, you talk to anybody who is dealing with software like STAT Pro or ETABS, they say that, oh, I just wrote an API to work with my software because I need to run so many different simulations and so many different designs. So that kind of an extension of what the software gives you is also very necessary, and this need is felt by many engineers who continuously work on these things. So we do our own software development as well. That's kind of important. So you need these extensions. And finally, if we want a software to play a big role, it should be easily accessible and affordable to everybody. And when I say everybody, it means also students who are included, because they are tomorrow's engineers, right? So and how do you do that? If you look at the right column, I think I'm trying to give you a one-to-one correspondence here. So for interpretation, what we do in our team is that we get all our design process, the whole algorithm, vetted by the experts in the domain, both from industry and academia. We'll talk about that. Then you can have the design reports and detail check, so there is enough transparency. The outputs can be standardized so that it can be reviewed by someone else who is not involved in the basic design. In terms of design automation, the workflow automation, in terms of interoperability, we can start, you always say that, okay, we can start with the model creation and we should go up to the good for construction drawing. So these are our goals, that's what we want, okay? And in Osdag, we are trying to incorporate things like that. We want to create IFC based workflows. For students who may not know what IFC is, IFC stands for Industry Foundation Class, which is the standard standard CAD or standard drafting framework through which one software can talk to another and create a smooth workflow from the architect to the contractor. Also, we try to create a simple user interface, and the workflow should be intuitive. If you want to do optimization, your code should be able to run very fast, and it should be also do this multiple times. So we create in an independent way so that it can do that. To provide customizability, to provide extensibility, we don't stop at APIs. We create a software in an open source framework so that we can, or anybody can take our software, learn about it, and add their own additional developments to our software. And finally, it's free, free as in free lunch. So it's free in terms of the code being open to everybody, but it's also free, so there is no question about affordability at all. So overall, what we are trying to do is to move from this costly software which operate like a black box to free and open source software. So I guess this slide kind of gives you what our ideals are in terms of developing this. Recently we are looking at some other software. I would not name the software, but they are also moving from a very black box like approach to open up certain parts of their basic engine, the basic code, and this is being done in many places. Okay. So now let's come to Osdag. Let's see if Osdag is able to do all these that we are claiming it should be doing. Okay. So Osdag, the focus is definitely on implementing what our design standard, primarily IS 800 says. Okay. There are other standards also which a steel designer would know, and those are also incorporated here. So it's very much focused on an India-centric development. But since our code is open, similar things can also be developed for other standards elsewhere. Okay, so it's not limited in that way. The primary two objectives that we had when we started developing this software is to aid the whole teaching learning process of structural steel design through software, through the use of software, through incorporation of software in a classroom environment, and also to provide an affordable alternative for practicing professionals, particularly those young professionals who graduate out of college and cannot afford to have a very expensive software on their desktop. So for those we started, okay. And it's developed as part of the umbrella project we call FOSS at IIT Bombay, and it's primarily supported by this National Mission on Education through ICT. That's one of the missions of our Ministry of Education, Government of India. There are other funding agencies who also have contributed to a certain extent, and INSDAG is one of them, so we are very happy to be here. So it's not just moral support, but INSDAG has supported us in many different ways. One important thing about our software is that our design algorithms, as I was saying, are reviewed and validated by experts from academia and industry. I'll show you who they are and how we manage them. So what are our motivations? I'll try to quickly go through this. When we started, which is around 2014, even before that, I continuously felt while working with other experts in this domain. I have worked with Professor Satish Kumar from IIT Madras, Mr. Manas Ghosh, who is here today, I hope, and we were doing many training programs. We are trying to promote the new Indian standard. It was new then, and we found that many of our structural engineers were not really confident in steel design. And when I say not confident, it doesn't mean that they didn't know how to do steel design, but it was not as easy for them as it was to do a reinforced concrete design. That's where the big difference was. Okay, so everybody was so comfortable in doing a, let's say, 3 to 4 story simple building frame or even a RC chimney, but still people were not so confident. Okay, and also for teaching and also for practice, we didn't have many guidelines. Yes, we had a TRM then, but as you can see, as you heard from Mr. Mishra, the TRM really needed updating. TRM didn't follow the updated code of 2007. And of course, commercial software costly, you talked about that. So all of this, it led to a lot of software piracy. Well, we are not very concerned about that in those days, but I think our culture has changed, and we are trying to come out of those situations. And many of the organizations are very serious about the kind of software they use, which is a very good sign. and but we are trying to take a different approach. We are trying to cater to everybody so that they don't have to suffer from this issue of not being able to afford some costly software. Instead, what people did, and people still do these things today, they use their in-house like Excel like spreadsheets, and those solution is passed on from senior engineers to junior engineers, and this is a very common practice because the softwares that we commonly use, they don't cover everything, right? And many times you would not have the whole analysis, design, detailing, everything in a single platform. So these are issues. But also there are other push, for example, the national steel policy that came out in 2017, uh, it pushed for more steel usage in the construction and infrastructure sector, and we thought that yes, by promoting an indigenous software, we can also try to achieve those goals that are there. Not everything, of course, but to a certain extent you can also push towards that direction. And what's the final impact that we are looking at? We thought that best case scenario is that we should be equally confident, if not more confident, in designing structures with steel, okay, throughout the construction industry. Our students, when they come out of the colleges, they should know what they have learned from their teachers. Teachers should not find it difficult to teach structural steel, so many specifications, IS 800. They should be able to do that if they are aided by a software. And those, those non-validated Excel tools or some other tools can be replaced by a proper software which are with us. And of course, we can maintain the standardization and quality control, which can happen with any software, and so it happens with our software as well. And finally, since it's a free and open source software, of course the firms, big firms, can save a lot of money. We are not saying that right now we are in that situation, but there are many things in Osdag that you will find out which can be adopted in a big consultancy firm for design as well. Overall, what are you trying to do? We are trying in our very small way, we are trying to contribute towards India's move towards this sustainable and low carbon future, at least in construction, by use of steel, use of structural steel in a big way. This is something we are trying to help through this as well. Now, coming back to the automation and interoperability part, to the left you can see a flowchart where we are looking at the typical AEC workflow. And today, BIM sits at the center of all the workflow, where you can start with conceptual design, then you go to engineering. This used to be the older one, right? And then you go for bidding, and then you finally, once you have the design, you go for fabrication, then construction, and finally commissioning. Now BIM sits at the center. The question is, in this overall workflow, where do we stand? Let's look at the engineering one. Okay, so within engineering, what do we typically do? Well, we first create a model, okay, and when I say engineering, I am talking about not mechanical, electrical, plumbing. We are talking about structural engineering, not even geotech part, which is not very far anyway, but we are talking about structural engineering. So we create a digital model, digital representation of a structure. We draw it on screen, we create, we assign the boundary conditions, then we assign material, sections, we assign loads, do an analysis. Once we do the analysis, we look at the codal specifications and we try to design. And if I am a good engineer, I will also try to economize or optimize the whole design. So Osdag is there. Osdag is not everywhere, but Osdag is at least in this green block and the other green block, okay. And in future we will definitely cover the 2 yellow blocks as well. So this is our goal. But Osdag is not only limited to structural engineering, as you would see. If we look at the fabrication part, in the fabrication part, we take the information for the structural designer, then do detailing checks. We also look at the conflicts in fabrication, so those constraints also we incorporate into our overall result, and then we export our CAD for fabrication, which then goes to fabrication. So again, here the green blocks are what Osdag does. Well, not 100% everywhere, but to a great extent it does everywhere, and this is where we also get into the industry best practices, because in our our team is supported by a group of experts that you cannot get anywhere else in India, okay. Of course, we are not going to get into fabrication, so I kept it in white. The rest is something that we are doing. I'll try to quickly go through the features of Osdag, and then afterwards we'll get to the details of it in proper demonstration of the software. So this is the Osdag main page. You can see how it looks, and the Osdag logo you can see to the left, and to the left at the bottom you can see also our institute logo, and the other logos are for those who have funded us, who have supported us throughout our journey and still supporting us. I'll just make you familiar with the thing. On the left hand side, you will see different modules that we have created. Not everything has been is ready right now, so certain things are grayed out. Then if you are a user, you are continuously using this, like many modern software, you will see that you can have quick access to the recent projects, you can quickly get back to them. To the right top, we have many other features for information, for plugins, for many other features that are going to come. It's not all there. Some helpful tips, etc. And then coming back to the modules, so how the design happens. You start by selecting a module. Here I am selecting the tension member module, and then under that it shows the sub module under tension member. So here you can see that we are selecting bolted tension member, which is bolted to end gusset. The other option that is there in the same picture is the one which is welded to the end gusset. So here we are doing design member by member, which gives a better understanding. So once you select that, you get this window, which we call a design window, which is divided into 4 primary parts. To your left is the input dock, and to the right is the output dock. In the middle we have the CAD window, where you see nothing here, and also log window, you don't see much. So obviously you start with the input window. In the input window, and I hope it is visible to most of you, you start with selecting, and there are selections, many options for this tension member. You have single angles, you have back to back double angles, you have angles in a star configuration, you have channels, and you also have back to back channels. So you select from that. Then you select how the leg is connected to the gusset. If it's unequal angle, you decide long leg or short leg. You can also select the material. The materials are given as per IS 800 or the referred to code, refer to that. And when I go to bolt, if you can see at the bottom, bolt specifications are there. You define diameter, you define type of bolts. In bolt types, I will show you. I'm sorry, there is some misplace here. In the diameter here, if you can see, we are selecting customized options. So you can select the bolt diameters that you can design with. So this dialog box lets you choose as many as you want to, or all these options are there. For bolt type, you can see there are options of bearing bolt or friction grip bolt. And again, bolt type also, you can say what kind of bolt grade you want to select. Here you can see that we have selected all the bolt grades. You can select some of them, you can select only one, depending on what kind of design you want to perform. If it's just a design check, you will just select one and see if that satisfies the code requirement or not. Then for thickness also, the same options are there. Again, you can see that we are going by typical plate thicknesses available, like 8 millimeter, 10 millimeters, 12 millimeters, and so on. There are other options like additional inputs. So this is typically for a professional. When you are the first time learner, you may not be able to figure out what these additional inputs are, but if you are an interested learner, it will not be very it will not take much time for you to figure out these things as well. So here, if you can see, we are talking about friction grip bolts, and we are talking about what kind of bolt holes are used. If you are familiar with IS 800, you know that there are standard holes, there are oversized holes, there are short slots and long slots, right? So these options are there. The slip factor, there is a table in IS 800 which gives you the slip factor. So our software is loaded with all the information that you have in IS 800. So when you are doing the design, the selections that you are making and what is the right kind of selection, it also hints to you that okay, you should select this here or maybe something else. It gives all the necessary information. And information is also there for what are the properties on the angle section, which we will retrieve from IS 808, the latest version from 2021, the connector bolt, connector plate, and some other detailing and design option, the design philosophy, it will all be mentioned there in the additional inputs. Again, it's always at the tip of your mouse, but it's not necessary that you have to put all of these. After giving all these inputs, which are also cross validated in certain ways, if you miss something, it will tell you that no, you have missed some information, and then you can press design. And you can see that so far the rest of the design window is blank, and once you click design, it takes a few seconds, maybe it's fraction of a second, depending on the kind of complexity the structure has. Finally you come to something like this, where you can see that the CAD window is populated with an image, the output dock to the right is populated with many numbers, and details on the section, details on the bolt and the end connection with the gusset, and there is a log window at the bottom as well over here. So once I have created a design, you can see that this whole thing gets logged, the input gets logged, and this is also a typical feature for any software. And you cannot change or edit any of the inputs anymore, because you have a locked design. You have to unlock it, then only you can change, and the moment you unlock it, this design vanishes. So this again becomes blank, it does a redesign. The CAD window is very intuitive. If you move mouse to any place and on any component of the whole structure, it will show the details, and here you can see we have put the mouse hovering over on the bolt, and it shows that what's the grade of the bolt, what's the diameter of the bolt, how many bolts are there, these details. Similarly, if you can place it on the angle section, it will show the angle section properties as well. If you want to take a better look at this CAD window, you can close the input and output docks by using these buttons, or even using the buttons that are here. So input dock, output dock, both have been closed, and you can get a much clearer view for the model that's created, the structure component that has been designed. Then there are more toggle options. This is for the viewport, how you want to change the viewing angle. You can see it from here. This is also our creation, something interesting that we can talk a lot about, but not here maybe. And of course typical functions like zooming in and zooming out, also you can use your keyboard to do certain things. Those facilities are also available. Finally, in another way you can look at the structure, the design component, is that you can look at different components in different ways. So here we have selected only the member, that means the tension member here, so it shows only that. Similarly, you can select the gusset plate, or you can select the whole model. So these selection options are also there to get better views. The whole idea of spending so much effort into creating these features on the CAD window is that many times our teachers and mostly our students are unable to provide that kind of a visualization of the design component that we are designing. So our imagination remains very limited to the numbers that we calculate with the units. That's where it stops, and we are trying to get out of that. We trying to give a feel of the structure or the member that we are creating. If you click on the generate design report over here, it gives you a dialog box where you can fill your details, who is designing, what is being designed, for who, etc., and it will create a design report. But it will also give you options to customize your design report. I mean, these are options that are there in other software as well, and you can find it in Osdag now, that whichever you want to do, you can definitely select them, and accordingly it will create a design report. Our design report looks like this, and I want to mention that this is something we are very proud of, because we can show all the detailed checks as per IS 800, and it shows all the detailed calculations and shows if it's passing that or failing a certain check. Okay. So this is quite critical for us, and that's how we created it. We have more outputs. So if you go to this file option and then select save 3D model, it gives you an option to select the type in or the format in which you want to save the CAD model, which you see there, and these are all standard types which are used in many CAD and drafting software. You can do that. One important thing, as I was mentioning earlier, is this IFC option, which is the industry standard for such operability and beam option. And here you can see our design that we created. The IFC file has been exported to a beam viewer, and how you can see the whole thing. You can see the properties. So you can see that the beam viewer can read all the details that are there for each and every section, which is highlighted over here. Similarly, you can take all other different formats also to typical CAD or drafting software, for example AutoCAD. Here we are showing that how an IGS file, IGS CAD file, the 3D model is taken into FreeCAD and you are viewing it, and this is this is a beam to beam splice with cover plates, and not for the same example of the tension member, just to be clear. And what we can do over here is we can use this to create construction drawings. The good for construction drawings that you see at the end of it can be seen from here. More of this you will hear or see when we give the demo. Let's look at how you can connect to us and how you can start using Osdag. Okay, and it's quite simple. Okay, all our information are available on our website, and when you say information, the information that a user needs. So this is our website, osdag.fossy.in. We mentioned about FOSSY. This is the umbrella project with which we are working, and if you go to our website, you can see there are resources tab, which is very important, and then there is downloads tab, forum, etc., etc. So we will talk about the downloads quickly. If you go to the downloads tab, you will find the installers. You can download the installers. There are detailed instructions. Instructions don't run for pages. It's very small, and download also happens very quickly. If we get time, we can give you a demo how the download happens. Probably will not happen. And I'd also like to announce here that we have very recently released another update on the version that we released 2 months back with many new features that you are seeing today. And this is available for download both for Windows computers users and Linux computers user as well. We of course do have a forum, that's I think very important. So we provide support which helps the community, also develops the community who wants to be in the steel structure and design domain in a big way. So you can be part of the discussion over here, raise your questions, doubts, how to solve this, how to solve that through this. We are also quite active on LinkedIn, which we use as an outreach platform. So all the releases are announced there and all feature updates. We also put a very small, very short video tutorials which you can use as learning resource. We announce internships and other collaboration opportunities, workshops, webinars like today's webinar, and if there are community highlights or other success stories, that also we post there. And obviously you can also use it for user support and discussions, but you definitely prefer the forum for this. We do many training programs, and it was being mentioned both by Munib and Mr. Mishra. We did a program in IIT Roorkee, he was mentioning. You can see Professor Ashwin here, this was in the Greater Noida campus. We did more after that. I think Parth can confirm exactly which date it was, I don't remember, but we have been doing such training programs for long back, and I think it forms a very important part of our work, developing awareness about our software. Now I will take a break. So Parth Karia, who has been leading this effort in multiple fronts, will give you a demonstration of Osdag. Okay.
Hi, good evening. I am Parth and I am working as a research associate for Osdag, and I'll give you a brief demonstration covering the features which sir talked about, but how does it actually look on Osdag. So we'll try to take up some classic textbook questions, like say this is a question on design a clit angle connection between two beams, which is say MB 400 and 250 for a factored design shear force of 40 kilonewton. It says that the bearing bolts available are for 12, 16 and 20 mm of grades 4.6, 5.6, 8.8 and 10.9, and the grade of steel is given. So when you have a question like this particularly pertains to something like you have an input from site. Okay, so now if I go to, say, it says a clit angle connection, so we'll go to a module connection, clit angle connection, then since it's a shear connection, we'll go to clit angle connection, we'll click on this and you will see a design window here, and it says the connection is between two beams, which is MB400 and MB250. So the primary beam is MB400 and the secondary beam is MB250. So I'll select it's connected to a connection of beam to beam. So you will see a representative image here. Then it says MB400. So here we have all the database as per availability in India and as per IS 808, and we have the secondary beam as MB250, and now it says that the load is 40 kilonewton and material is E250. So we'll select E250A, load is 40 kilonewton, which we'll type, and the available bolt diameters are 12, 16 and 20 mm. So I'll go to customized, and I will move all the selected ones on the left side, and which I want to select, which is 12, 16. So you can either double click, you can select and click, and then 20 mm. So this is 12, 16 and 20 mm, and I will do say submit. So these are selected now. The bolt type is bearing bolts and the properties are again customized. So it is 4.6, 5.6, 8.8 and 10.9. So I'll again press this button to move all on the left, and 4.6, 5.6, 8.8 and 10.9. okay, and I'll press submit. Now I have covered all of these things. So it says but here we have one more input, clit angle. So which angle we will select? So here we'll try to introduce the concept that Osdag does two types of thing. Either it does a design checking problem or an optimized design. So here, since we have not mentioned, we will go for an optimized design. So we'll come here and just select all, and after this input doc is done, we'll just press design, and within a few seconds you will see a design. Here all the features which are available for CAD, like when you hover over this material, you will be able to see its designation, you will be able to see the angle that has been used for design, the clit angle. This is our view cube, which is developed primarily by us and our interns. These with apart from this view cube, you can also use your click to scroll. You can do a zoom in and zoom out with the cursor, and you can pan if you click your cursor on a mouse. You can also isolate certain materials and see. Now if we'll go to model, and if we will see this view, we can see we have tried to incorporate a very traditional and fabrication practice where we are trying to keep the beams at the same level and giving a cut, and this gap, everything is also defined in additional inputs. So these are the CAD features, and now we can go here, we can see the output doc, which has all the designations, the height, the length of the angle, number of bolts, etc. Now something that has been done recently is when you click on capacity, you will be able to see clearly the block shear failure patterns that can happen in the plate, the block shear failure patterns that can happen in the beam, and the block shear failure pattern because of the web failure of the primary beam. So all of these things have been incorporated, and it will be essential for faculty members to teach their students on how the block shear failure pattern occurs across two lines of bolts, four bolts, or say 3 cross 2 lines of bolts, etc. So apart from this, now you can click here and say do generate design report, and here you can give in all your details, and if you don't give the details, that is also fine. You can press next, and here you can select what you want to print in the report. or if you want to print everything, or if so now I'll go for a preview PDF if you want to check the PDF before you print. So here this is how the entire design report looks like. It will have the input parameters, it will have the design check. Here this is the main part we begin with. Like in the beginning we tell you that the member has passed or failed, then the data of the selected member, the design checks, which is the all the capacities. In the report you will see that the clause numbers are mentioned clearly here, low shear, high shear conditions. So it just doesn't come with the calculation, but also some comment, some reference on where these values are taken from. Here till here it's a design check, then we go to detailing, we select a bolt diameter, we check the pitch distances, edge distances, which are very essential in designing and detailing. So say our report will end with something like the views, and it has the design log also, which you can print, which we haven't printed. Okay, so now I'll go back to Osdag, and this was the clit angle connection. Now we'll go to another module. So here you have the sidebar from where you can navigate between modules. You can select connection again, or you can also select home. Here we go to so this is the second question that we'll do. Design a bolted splice connection for LB 400 beam for a factored shear force of 75 kilonewton, factored bending moment of 45 kilonewton meter, and we have to design the most optimum connection using friction grip bolt, which has the flange plate only on the outside. So we have to take E350 Fe490 and assume the coefficient of friction as 0.48. So now this is a connection module with a beam cover plate bolted. So when we come to Osdag, moment connections, beam splices and cover plate bolted. Okay, we are here now. So now our designation is LB 400 and material is E350. So this is LB 400, E350 is selected. Our load is 75 kilonewton and 45 kilonewton per meter. So bending moment is 45 and shear force is 75. Flange plate preference is on the outside. Okay, it says friction grip bolt with a coefficient of friction of 0.48. So as Professor Ghosh discussed, we can select the bolt type here, but when we go to additional inputs, here from additional input we can select the coefficient of friction, save. Okay, now it doesn't say anything about the bolt diameter, property class or thickness of splice plates as discussed. Okay, so bolt diameter, then we'll select all, since the question says that we'll go for an optimum connection design. Bolt grade will select all. Flange splice plate thicknesses and web splice plate thicknesses also will go for the most optimum design. And we press design. So now you have the CAD view which has two beams connected with the splices, and as you can see the flange plate is only on the outside. Now this is the optimum design that we have done. So if at this point if you would want to save your design for future references, you can use save input function and you can choose a directory where you can save. Then there is also an option of save project. So when you go to file and say save project, and I will save this as so now it will say the project has been saved. Okay, so now with the side nav bar, if I again go to home, I'll be able to see this project here where I'll be directly able to download the report from here, download the inputs from here, or open the project from here. Now we'll see another feature here, which is save 3D model. So as we discussed in save 3D model, we have 5 options where you can save as an IGES file, as an STTP file, as a STL file, .ifc and .brep. Uh, IGES is the most commonly used for CAD softwares like AutoCAD, FreeCAD, etc. Although FreeCAD will import all, but say IFC, which is Industry Foundation Class Drawings, will be used for BIM workflows. So when we import these files into, we save this as an IFC, and we import this as an IFC in Revit or any beam viewer software. At that place we'll also be able to see all the data related to the sections, as we saw in the features section. So say the load will be able to see the designations, etc. So in the end-to-end workflow of the design, this becomes a very essential point. And the so this is the second question, and we move to a third question, which is a recent development. So here the question is, design a 6000 long plate girder with thick web for a factored shear force of 60 kilonewtons and the bending moment of 125 kilonewton meter. It is a simply supported and a major laterally supported plate girder with both flanges fully restrained. We'll take FE 490 grade steel and FY 350. Assume the bearing length as 150 mm and other data if necessary. So the module is flexural members and plate girder. So from here we'll go to flexural members and plate girder. So the material is E350, the length is 6000 mm long. So I'll just say 6000 mm long. It is a major laterally supported. Currently Osdag just provides support or say design for a simply supported plate girder. It doesn't have any other modules for support conditions as of yet. So by default it will be a simply supported plate girder. Bearing length is 150 mm, major laterally supported, and we are doing a thick web without ITS question, and it says both flanges fully restrained for warping restraint. So here both flanges fully restrained we have done, and 125 kilonewton meters of bending moment and 60 kilonewtons of shear force. So 125 kilonewton and 60. And now what will we take as the depth, flange width, flange thickness or web thickness? It's a plate girder. It's an open-ended question. So in a typical beam design, when we do it with rolled sections, we usually take the bending moment, calculate the required plastic modulus, and then based on IS 808 tables we'll select a member and do the checks. But here what should we do? So, and with a single particular plastic modulus there are a lot of options, and how do we optimize this thing? So in the recently introduced plate girder module in Osdag, what we are doing is we are using an advanced optimization technique which is called particle swarm optimization, and I'll give you a brief demo of that. So now I'll just press design, and you see this optimization window which is developed. Now you see that here beyond this screen, these are the failed members, these are the past members, and you see the iterations are occurring. So there are around 100 iterations with 50 particles in each iteration, which will go and give you the best design, and you will be able to see the member here on how it's optimizing. So why we are going for such a large number of iterations, because it will take some time to iterate, is that we want reliable answers and repetitive reliable answers. So large number of iterations will give us this benefit. So now once these iterations are done, a correct design is loaded again in the window, and all other options are available. And if you want to see the report, you can see The report for this same question, it will have all the values of the section here, followed by which it will have all your inputs. It will give the design check, does the section classification, and all other design checks like shear capacity, moment capacity, and deflection. Okay, so these are the three questions that we tried to cover different features and aspects of design capabilities of Osdag, and yeah, that's for the demonstration part. And I'll now request Professor Ghosh to again uh, give the concluding remarks.
So I hope you had a good time listening to Parth giving the proper demo of our software. So I'll continue and we'll try to wrap up soon. I see many questions. I was going through them with others in this, and I'm happy to see that you are so very interested in this. So this is our current team. You can see some names here. Of course, you met Parth already. There is Ajmal, Ajinkya, Nidhi, Radhika, Christo, Swastik, Aditya, and many interns, and interns form a big part of our whole team. So this is something that I'm going to talk to you about soon. Just a quick brief on how we develop this. So to your left, you can see that this is the flowchart of how we create a new module. Okay, so you select a module to be developed. We create a DDCL, that is design and detailing checklist, and then our expert review panel goes through that and sort of weights that. Okay, and you can see our expert reviewers, and if you have been involved in structural steel design in India, you know most of them. Mr. Mishra was naming a few of them here. INSDAG has also been involved. So once the review goes through, then you go for development. And although we have kept a single block here, I know that most of us in this webinar are from civil structural engineering background, so we don't want to talk more about development, but that's the big part. Development has many small parts which we are not discussing here. Once we develop a module, we have to go through comprehensive testing. This is part of every software development, and that's very important. And once we think that it has satisfactorily passed all the tests, then only we go for release of a module. And of course, it gets integrated to the existing software. The available modules you can see, we started with connections, so we are quite good with connections, I would say. But we also have added different components, so tension members, compression members, flexion member, including plate girder. You just saw one example of plate girder. This is what we have done. What we haven't done yet are the systems. So someone was asking that can you design a full building? Not yet, we cannot do that. But I will show you something that will tell you that we have the abilities, we just need time to develop those modules. So soon we will be able to do full building design for that. Currently the modules that are under our work is laced and batten columns. In flexible members we are looking at purlins for primarily for roof trusses, castellated beams, and also gantry girder. Gantry girder we are kind of ready. And then we have plugins. Plugins are not really modules, but plugins can also be modules. We will talk about that. What's next? What's coming next? We thought that although installation of Osdag is simple, but many times you would like to try it out without getting busy with our desktop, getting a file from somewhere. Is it working on my operating system or not? The same version works, or hardware is sufficient or not? We thought that we will let people try it out on the web. And you will see that many of the software has moved to the web and they work on a rental basis. Well, for us, of course, there is no rent, right? So there is absolutely rent-free system that we have and that we are going to create. So with this one, we will be able to just log into our website, and the screenshot that you are looking at is not our web server, but a local host. But you will have something like this where you should be able to log in using basic authentication and perform similar tasks as well. Of course, we will create a responsive user interface so that it would work on PCs, tablets, wherever. And we will have authentication, something like what you see using Google or using some other option. Everybody has a Gmail or Google account, so you should be able to log in. You could be able to retrieve your files, and this is what we are planning next. Now coming about the plugins, what do the plugins do? Okay, so primarily you have the main Osdag that you are creating, but Osdag will let you plug many other modules in. It could be modules, it could be extension, it could be something that you can add to this, and this is something that you can add, right? So this is your own module that you can create. And how can you create? Because our source is open to you. You can read, you can study, you can understand, and soon we are going to come with developers manual as well, using which you can create your own module. So not just APIs, but the complete thing. Okay, and these plugins, if you want the it to be integrated with the official Osdag, that also can be done with proper testing, etc. You can integrate it with the official Osdag release, or if you want to just keep it for yourself or your organization, that also you are free to do. Okay, so it gives you a lot of freedom in how you want to use Osdag. So one upcoming plugin that we want to talk about, I'm sorry for the spelling mistake, it sounds very bad. Uh, it's an upcoming plugin. This is Osdag Bridge. This is the first system design that we have tried, and instead of developing on simple building frames or trusses, we went for this because there was a specific requirement under the project where we are working on short span bridges. So these are short span bridges with steel plate girders and a composite deck at the top, and it can span from 20 meters to 45 meters, typically meant for highway bridges. And we are almost very close to releasing the software soon. So this is one development that is happening. You will soon be able to see it on our Osdag channel or maybe LinkedIn announcement. A similar work, not similar, a related work that we have also been doing, again this was based on a requirement for a specific project where we have funding. It was for life cycle cost assessment. Now many of us may not be familiar with life cycle cost assessment. I would definitely urge you to look into this, and this is something we are creating where life cycle cost can be assessed throughout the expected design life of a bridge. Again, this is for bridge primarily, but later on we plan to extend it to buildings and other structures as well. The interesting part over here is that this includes not just the economic cost, but the impact on the environment, impact on the society altogether. And there, it's based on a framework that we created at IIT Bombay called CPS-LCCA, and we are creating this tool as well. In terms of modules, resources, and other developments, what are we going to do next? So we will pick up a systems analysis, right? System analysis and design. So we are going to see how you can design a whole truss, not just a truss member, not just a tension member or a compression member, but the whole truss. How do you do truss connections? Look at most structural steel design software. They won't tell you how do you design a gusset plate where 5 different members are connected, right? They will not give you the individual details. That for that you have to go to a very specialized software which may be costly, and you may not have access to that, right? So these are challenges you would like to solve for you. Also you want to work on the beam column module, that also will come next. But other than that, other than module development, we are also working on resources development. For example, we are going to create textbook companion, which will give you what? It will give you many sample questions and their solutions based on let's say popular textbook that is being used by many people, okay, in India, of course, because we are using IS 800, right? And then our task is to come out with user manual. Right now Osdag doesn't have a proper user manual like many other software would have, but what we find is that most of the times you don't need it that way, although what we provide is many tooltips which can be used to get there. The other thing that I want to say here is that we want to be more active in terms of engagement with our user base. We want to create the user base, broaden the user base, and help them with their problems with structural steel design. And the user can be students, can be teachers, can be young professionals, can even be very senior professionals or even organizations. Okay, we want to do training programs, we want to do more webinars like this and hackathons. So yeah, we are going to probably announce for one hackathon soon, and that's going to come. What I'm and the whole team is coming here to tell you is that I want you to be a partner with us in this development. Okay, we want partners. If you are a faculty member, we want partners. If you are an industry professional, we want partners. Even if you are not associated in your organization, individually itself, beyond your work time, you can collaborate with us. Okay, and I'll talk more about the students how they can. So if you are a college teacher, okay, how can you collaborate with us? You can be our faculty partner. We can help you in enhancing your teaching in the classroom or lab environment. We can help you to integrate Osdag into your theory and lab courses. You can create assignments, projects, which you can do, hand calculation based solution. Parallelly, you show Osdag and you show all the details. Partha was showing you how block shear failure is happening. If I remember correctly, it was a primary to secondary beam connection with clit angle. So how these things happen, hardly any book will tell you, and even if they tell you, they won't give you the visuals. And for engineers, visuals are very, very important. We can't really go without those visuals, right? So we can help you with that. We can help you with setting up projects, conducting them, evaluating them, and so on. Also, you can conduct workshops for teachers, and we can help you to mentor interns for us. For industry, the biggest thing that you can do is that if you have a very specific requirement, let's say you need, for example, you need to find out a software module where it gives you hollow section connections. That's one example I can think of top of my head. We can create that for you. Okay, so this is on request module development that you can do, and you can also be a partner in the sponsorship. So along with the names of Ministry of Education, Ministry of Steel, your name will feature over there as well. We can also train your workforce. If you find that training on Osdag would be beneficial to them, we would be very, very happy to do that. On site or online, both can be done. And of course, you can collaborate with us in many different ways that we do at IIT Bombay. We are just giving you a very top of the iceberg kind of presentation over here. For individual developers, if you are, if you want to go beyond your regular civil structural engineering, there are many things that you can do. You can contribute in module development, contribute in feature development, features like, let's say, graphics, features like going onto the web, and also you can help us in resource development. Okay, problems, solutions for textbook problems. This is something that you can do. You can help us promote Osdag and other FOSS tools in academia and industry as an individual. You can also help in supporting students to participate in many FOSS programs, including internships. So talking about internships, let me go there. So this is a recent announcement, but what I want to say is that we have many interns doing internships around the year, and typically undergraduate but also postgraduate. We offer internships through summer, winter, and whole semester long internships. And what we find that the most of our interns, they come back, they continue, extend their internship periods. If we can do that, if their situations allow them to do, they do come back. And it's open to all engineering and science students and graduates, not just civil engineers, because we have been helped a lot by people come from mechanical engineering background, computer science background, electrical engineering background, IT background. So we can take all of your help, and you can be part of the whole development. You can work from home, you can come to Mumbai as well, you can work as full-time or part-time, it's up to you, it can be decided. Typically, we select the interns based on a screening task, which is done online, which is oriented towards what you are projected to do at a later stage. Okay, so please make a note of the summer internship that FOSS has posted very recently. You can see the banner to your right. The last date for task submission is 13th April, so it's coming soon. If you are a student and interested in partnering with us, don't miss out the deadline. Okay, for Osdag, we have screening tasks in civil engineering and software development, and for the details, you can note down the website or scan the QR code and get there. And with that, I'll stop over here. Again, thanks to INSDAG for letting us be available and to all the participants today, and also to tell them about what we have been doing at IIT Bombay for a long time. Of course, other than INSDAG, we have to thank our sponsors. We are working under FOSS, as I said, which comes under the NMICT project of Ministry of Education. We are also funded by Ministry of Steel. We are also funded by Construct Steel, which is a subsidiary of World Steel Association. And all of their efforts finally come to this to a certain extent. Okay. So again, our contact details are here. Our LinkedIn page is here. I hope that we haven't taken much time. So again, thanks to Parth for helping me with the demonstration, and thanks all the whole Osdag team for making this presentation possible, and obviously thanks to Munib and Mr. Mishra and the INSDAG team for letting us make this presentation today. Thank you.
Thank you so much, sir. And thank you to the OSDAG team for the detailed and insightful session. In fact, sir, I have also been using OSDAG lately. I talked to Ajmal and Parth, and in fact, the UI UX, it's very user friendly. The tool is very user friendly. It's very easy to use. You can see tutorials, and it's very easy to download as well. It just takes 5 minutes to download.
Yeah.
So, thank you so much, sir, for the insightful session.
Let me add
Yes, sir.
one thing, that we
Yes,
have
sir.
a newer version. Last version was big upgrade was there on Feb. I think a day or two back we'll announce it officially. But there is a new version which you can again download, or there are upgrade options also from your old download. We'll inform you about that. It will come soon. Yeah, please
Yes,
continue.
sir. Thank you. Thank you, sir. Thank you to Par, thank you to Ajmalji and to the whole OSDAC team for making this possible. And I'll also thank my colleagues, Dr. MM Ghosh sir, Sheila Ditta sir, Mishra sir as always, and all my other colleagues. In fact, Siddharth is on the other screen and he has also been pivotal in making this program a success. INSDAG is doing to upskill our younger masses, faculties, professionals, and students. And I can also see Tukral sir. Tukral sir, namaste. So good to see you again to join this program. So
Sir,
thank you so
I
much.
just want to add a couple of words and
Please,
which
sir,
will be
please.
helpful to Dr. Ghosh also, if you permit me.
Yes, sir, please, sir, please.
Sir, this whole idea of this from design, once we move to the workshop, there is a definitely uh, mismatch which comes that the material is available or not available. So I would request that sort of a plugin or something like for us as producers, we can give it to you that it becomes in the part of your software itself that these are the rule sections which are readily available, or this you have to work to them. Like even the one example which was shown, you talk of this LB 400. I think there nobody in India is rolling it.
Yeah.
So we if if you give us an opportunity somehow that this is our product range that which we produce on regular basis, and that gets integrated into your software, that becomes a ready reference that such and such material is available and such material you'll have to look for alternates. That
That
is
would
all.
that would
Thank
be
you.
very helpful to us. Thank you so much for the suggestion. Yes, as you said, LB 400 nobody is using, nobody is producing. It's just for a academic presentation we did that. We had this idea of what you were suggesting. We had this idea earlier. Someone also suggested exactly the same thing, and many of us who stay within academia many a times do not understand these real situations, that I can ask for something and may not get it in the market. For example, we showed you some example with unequal angles, and I don't know where to get unequal angles except for textbook. But
Yes.
finally, we went for IS 808 was
Yes.
revised and updated in 2021. So we included everything that is there in that code. But I think it is a good idea to talk about
No.
market availability of sections as well.
Dr.
Maybe we
Ghosh,
can.
I am in Mumbai itself, and if you want, like, I can come down and meet you, and like we can discuss how we can go about it.
Thank
So
you so much. We'll definitely do that.
Munib has my contacts.
Sure, sure.
Yeah,
Yes,
Thank
I'll
you.
share, sir.
thank you.
Thank you. Thank you, sir. Thank you, Tukral. Uh, Before we conclude, I'd like to briefly highlight that for this year, we have compiled a comprehensive training calendar. And in fact, the OSDAG webinar was the first training or webinar that we did for this year. I'll show it to all participants. So this is our comprehensive training calendar for this financial year, that is from April 2026 to March 2027. And I'll just quickly take you through the different programs that we are doing. The OSDAG one, this insightful webinar, this was the first webinar that we did for this financial year. Next, in May, we are doing one paid online training program on IS 875, that is on winds. And this will be very useful for students, professionals who are entering into the field. Then we are doing one on pre-stressed steel. This is also one new program that we are doing this year. Then we are doing a program on cold form steel construction, again a topic which is very important and very upcoming in these days. We are doing one on steel concrete composite structures, another topic which sees a lot of traction from the industry. These are all online programs, mind you, and these are, if you can see, I'll send you all these details after this program. These are all online. Well, most of them are online, and most of them are for 2 days, 3 days, 4 days. We have one on quality essentials in steel structure fabrication. Now, again, a very important topic, and this will be offline. It's in the month of Aug. Then we have one on steel connections design using software tools. Again, a very important topic. This year, we are doing for the first time, we are doing a program on sustainability. Now, will be an online training program, and this will be for civil engineers, sustainability for civil engineers, how you can actually calculate, just like how you design structures, how you can actually find sustainable parameters. So, this is again a very useful program that we'll be doing this year. We'll be doing another one on health evaluation of structures, retrofitting measures with steel. Will A lot of talk on bridges was there in the program, so we'll be doing one program on steel plate girder bridges for this year. Uh, then we'll do one. Now, this is a very interesting topic that we'll be doing this year, that is on complete design of an industrial steel structure. This will be guided by our TRM, and this will be really useful to students, to practicing engineers who are just entering into the industry. Uh, then we'll do one practical guide to design and detailing of a typical steel frame commercial structure using software tools. So these are what we have done most of our trainings, as we are seeing most of us are moving into AI and software. So we are also focusing our training programs to such things. Then the final one would be smart construction with prefabricated steel structures. So total we'll be doing around 10 training programs. Uh, Now, the reason I showed you this training calendar, and we'll be circulating this training calendar to our participants who have joined this, is for a limited period of time, you can actually enroll in any number of choice of your programs. Like you can uh, choose 4 programs out of the ones I showed. You can choose 6, you can choose 8, you can choose 10, and accordingly the costs will be giving discounts based on that, and these discounts will be just one time, and this will be at the start. uh, so we'll encourage people who are actually in this meeting and who are seeing this, you can go through this calendar, and if you find useful, you can select any of whatever you find useful. You can just select those, and you will be charged based on that. There will be an additional 30% discount over and above these discounts for INSDAG members, both professionals and students. Uh, Now, another thing which I wanted to show is, this is one training calendar. We'll be circulating this to all of you. Another thing, we were discussing about TRM, teaching resource material. So, in fact, Mr. Mishra was speaking about TRM and how it can be useful. So, we'll just show a video of what is there in the TRM. Teaching resource material is basically a document which covers all the aspects of majority of aspects of steel design for structural engineers. It is available on our knowledge portal. So I'll just show you a quick video which will show you what TRM is and where is it. So yeah, this TRM, what we are talking about, is for structural steel design, and it is for structural engineers. So this TRM is currently available on our knowledge portal. Uh, and I'll send you the details of knowledge portal as well. And other than that, we are also doing one TRM for architects. That is currently in progress that we are doing with the help of IIT Roorkee and others. So that will also come out. So these were the two things that I just quickly wanted to discuss with all of you. One is the training calendar and one is the TRM. And for both of these, we'll be sending the details to all of you. Uh, I think that would be it from our side. Professor Ghosh, anything else to add, or any other colleague?
Nothing
Thank
from
you.
my side. Very happy to be here. Yeah.
Yeah, thank you so much. Thank you so much, Professor Ghosh, and thank you so much, everyone. I think we can call it a day, and thank you so much for joining this webinar on a busy weekday. Uh, Thank you so much. We can have a good day.
Bye. Good day.
Bye. Thank you.